Hi, my name is Tommy Perniciaro. I'm a solutions architect with No Name Security. Thank you for joining my talk today. It's labeled "Using Data Science to Help Secure Your API Estate." And what I thought I would do, since we have the short time of 10 minutes to do this little talk, is go through a little bit of the backstory of data science and cybersecurity, the state of API security, and some of the things you might want to think about before applying data science to an API security strategy. So, just a little on the backstory here. Why data science and cybersecurity is necessary. If you look, if you look at some of the news articles out there with the cybersecurity job shortages, it's no shocker to see there's far more jobs than there are qualified candidates. Another thing is the goalpost keeps moving quite frequently on skill sets. So the skills required to stay current are changing very rapidly. Another thing is, humans monitoring network and security events just plain out doesn't scale. And manually examining terabytes of data to surface threat patterns doesn't scale as well. I came from a long history when I first started out of designing and architecting and operating networks, and actually taking on attacks real time behind the console. Back when the IDSs were in place on the edge, you would have to decipher through terabytes of data just to create a snort signature. And if you look at the events of today and how sprawled out the infrastructures are and the sheer number of devices in these networks, it's impossible to do those things now. So what exactly is data science and how does it apply to cybersecurity? So what I like to think about when I think data science and security is data science is applied to security is the art of using artificial intelligence, machine learning, data mining, and visualization to detect threats and networks against and digital assets. The first successful solution, in my opinion, was malware and EDR, which is endpoint detect and respond. So if you think about just back when antiviruses were a thing, McAfee, Symantec, they would get a virus, on an end station. They would get it, they would reverse engineer it, and they were able to build what they called a signature. Well, malware engineers got smart, and they very easily and very cheaply were able to take that same virus and make it work again, but make it look different. So those signatures rendered themselves useless, and it was a very taxable process to keep creating those signatures. So what the malware industry did was said, hey, let's try this data science thing out. So what they did was they had supervised learning. What that is you have a known good set of behavior and a known bad set of behavior, and you start to train those models differently. And they both train themselves up, and you get this end result of a model that knows the differences between what's good and bad. And that coupled with the signature-based approach really changed the malware industry. And if you guys can see it, players like CrowdStrike, SentinelOne really ate that industry up. That to me was the first successful venture of data science into cybersecurity. So the current state of data science-based platforms and use cases in cybersecurity, there's a lot of hyperbole in the market from marketing teams. You'd be hard pressed to not find a product that doesn't advertise in some way its platform has the ability in some parts to have AI and ML attached to it. Not all bad, a lot of it's good. And there's still some very good use cases for data science-based platforms that are in production today. The first one I spoke about was malware. The other ones are things like NDR, like network detect and respond, to where these vendors are taking big collections of network events from different customer environments that are anonymized up in the cloud, and they're able to run data analytics on it and see different techniques and procedures that these attackers are using, and they're able to quantify that, build signature models and approaches, and be able to block that behavior in other customer environments before it happens and be a little proactive. The third one here is there's massive shifts in cybersecurity technology and operations, and data science is driving the change. A lot of the security operations groups that are in play today use data science to sift through thousands and tens of thousands of events every day to give them actionable insight based on the quantitative analysis of those logs that come in sheer huge volumes of terabytes of data per day. So the current state of API usage and attacks, if you look at three of these quotes here, so according to Akamai, more than 83% of its traffic as a CDN is API traffic. And that's changing in a few different ways. If you look at from a desktop, laptop user perspective, we now have Chromebooks, user laptops, hooked up to corporate networks. And a lot of those corporate networks are hooked up to cloud services for their IT delivery systems, things like Box, OneDrive, things like that. So those are delivered sometimes over HTTP, but in the middle of there, what makes it work is API calls. So if you look at that change from a plumbing perspective for infrastructure, things like firewalls, web application firewalls, they know where those users are going, but they don't know what they're doing. They don't know if this user is downloading a document in OneDrive, if they're creating a document in OneDrive, and so on and so forth. So there's a lot of blind spots now with so much of this traffic being API based and not HTTP. Also, according to Gartner, 40% of all the web attacks targeted APIs in 2020, not the standard web user interface. As well, Gartner predicts that API attacks will constitute the single greatest attack type amongst all cyber attacks by the end of 2022. And we're quickly approaching that date. Another quote here, which is one of my favorites, is every API I hacked was protected by a WAF. And if those of you who aren't familiar with Alyssa Knight, I would definitely suggest, if you're interested in API security, do some research, go look at her previous videos, blogs, posts. She is probably the leader in the space when it comes to API security, and definitely take a look there. So some of the key challenges to securing API security, the security models, the process, the technology, and the skills, they're poorly suited to secure APIs. That is a landscape that's ever changing. So it's really hard to wrap controls around API security right now with the existing tool sets at play. The product owners and developers usually have inconsistent awareness of the API security risk and controls. Usually those product owners and developers are not familiar with the controls that are in place. And some of the controls that are in place don't necessarily integrate with their tool sets. So that's a huge blind spot. The API development commonly occurs outside of where traditional controls are applied. Asset management, testing, change control, operational modeling. Those are all controls and models that are geared towards traditional IT and web applications. So they don't really fit in there. And when a mistake occurs, it happens fast and it's easy. Lots of data. If you guys have watched in the news, Parler, Experian, I don't have to name them. A lot of the recent attacks are definitely API based. API standards are well established, but adoption is inconsistent. So some of the challenges there. So what's needed? This is kind of, where we really, put the rubber to the road with some of these solutions and try to find a way for data science to figure out what it's done, in other cybersecurity controls and do the same for API security. So if you guys are familiar with XDR, that's extensible detection and response, what that is it's a number of tool sets, email delivery systems, intrusion detection, firewall, network switches, load balancers. It's accumulation of different controls that are reporting to the same location to where we can start to run analytics, behavioral analytics, big data techniques around some of those patterns and start to label those behaviors inside that data. The data lake approach, that's definitely going to be something that's needed for this. As much as data as possible around devices that understand context around APIs. So right now, if you look at a lot of the web application firewalls are deployed to protect APIs, but the messages that they're sending back into those data lakes and XDR tools, they have no context around the API. So it's really hard to surface up any type of meaningful labels or behavior analytics or big data techniques around that, since there's no contextual information around APIs. The third thing I have listed here is a comprehensive API discovery. A lot of teams and companies now, they don't know what's in their API estate. They haven't done the hard discovery. A lot of it's manual processes. So we need tools on the network that are listening to network traffic and that can do the discovery on those APIs. The fourth thing I have down here is behavioral machine learning models. So creating behavior models around each API, so we know, what's common around this API and what's out of order, to start to build out those anomalies. And then SOAR playbooks. SOAR playbooks, they're pretty new, but using contextual information around APIs to alert other tool sets to maybe make actionable policies, like authentication systems, API gateways to restrict usage from a certain user that might be, abusing a certain API, things like that. Leveraging the existing tools that are out there. Get to know your SIM and your third-party integrations. Most of the teams out there have a SIM platform. Get to know it. Get to know those third-party integrations. There's probably a lot of good data that's in that SIM that could be matched up with API-based contextual information as well. And then use some of that machine learning to generate attacks and generate tests. Each of these APIs are unique. They all need to have their own unique tests associated with them and their unique attacks. Not one attack is the same for another API. So that's very important. And the last thing I'll leave you guys with, I know we're out of time here, is there is no data science for API security without context. And I'll give you an example real quick that, WAFs don't understand context around APIs. They don't detect logic-based attacks like authentication and authorization vulnerabilities, mass assignment, excessive data exposure, and other novel threats that target APIs. They just don't. And it's without having that information being logged into a data lake or an XDR platform, it's really hard to draw labels and build behavioral models around that. And thank you very much.